the last video, we looked at some absolute value equations. And now here in this video, we'll look at some absolute value inequalities. And it's so important to grasp the definition of what absolute value means. The absolute value means we're looking for things that have a distance. We're looking for the distance from zero. So if we're saying that the absolute value of x is less than 6, then we're saying the distance from x to 0 is 6 units. So we could get to 6, it's less than 6 units, I'm sorry. So it's less than 6 units if we're somewhere here between -6 and +6. So we could say that x is sandwiched between 6 and the opposite of 6. And the way we write that in interval notation is parenthesis -6, comma 6, parenthesis. So we're saying the interval of numbers that go from -6 up to +6 have an absolute value that's less than 6. The distance from 0 is less than 6, either to the right or to the left of 0. Well, now for this next one, we're saying that the absolute value is greater than 9. So we're starting at -9 and 9 and going out from there. So that's going to be when the 3x minus 3, start with this easier one to comprehend, this 3x minus 3 is greater than 9, or 3x minus 3 is less than the opposite of 9. So that piece inside the absolute value, the 3x minus 3, has a distance from 0 that's more than 9 units. So that means it would be less than -9 or greater than +9. All that's left to do now is to solve for x. So I could add 3 to both sides and get -6. Divide by a +3. And I have x is less than -6 divided by 3, which is -2. Or add 3 to both sides and get 12. So 3x is greater than 12. And I can divide both sides by a +3 and treat it the same as I would an equation. And so that would give us x is greater than 4. Now, when I look at the number line, again, I'm going to repurpose this number line now and put in these two pieces here. I'm going to say x is less than -2. So that's starting here at -2 and going to the left, out to -infinity. Or starting at +4 and going out to +infinity. So you see the interval notation falling right off of the page here. And so what the interval notation would look like is this: the opposite of infinity, the -infinity, up to -2. I'm putting in a parenthesis because we don't include the -2 because this inequality symbol said greater than, not or equal to. Or, and I'm using the union symbol here, or from 4 to +infinity. And there's our answer in interval notation. Let's look at a few more examples. If I have the absolute value of x greater than 14, then I could start at 14 out here and -14. And if the distance is greater than 0, I'd be working outward, right? So I could see that that's a -infinity up to -14, or 14 to infinity. And again, I can't stress enough how important it is to focus in on what does the absolute value mean. The absolute value means a distance from 0. So what I'm saying when we're looking for the absolute value greater than 14, we're looking for all the x's that are more than 14 units away from 0. So that'd be anything from way off to the left at negative infinity up to negative 14, because the absolute value of negative 14 would equal 14, so we want anything to the left of that, or the absolute value of 14 is also equal to 14, so we could go from 14 to positive infinity. Let's look at a couple more examples. So the first step here with this inequality that has add 8 and multiply by 2, the first step is going to be to simplify the inequality to isolate the absolute value. So I could subtract 8 from both sides, and I would have 2 times the absolute value of 2x minus 1 is greater than 18 minus 8, which is 10. And then I could divide both sides by 2, and because it's a positive 2, I can treat it like an equation. Just a reminder that if I were dividing by a negative number, I have to flip this greater than around to be a less than. 2 divided by 2 is 1. So I have the absolute value of 1 times the absolute value of 2x minus 1. And that's greater than 10 divided by 2, which is 5. And now we're ready to look at a number line and say that we want all the values who are more than 5 units from 0. So that would be going from negative infinity up to negative 5, or from 5 to infinity. So I'm going to say that this 2x minus 1 is less than negative 5, or 2x minus 1 is greater than positive 5. When I solve for x, I could add 1 to both sides and get negative 4, divide both sides by 2, positive 2, so I don't have to change the inequality to get x is less than negative 2, or adding 1 to both sides here gives us a 6. So we have 2x greater than 6. Dividing by 2 gives us a 3, so x greater than 3. So we've got x's less than negative 2, or x's that are greater than 3. So if I put that on a number line, and the reason I go back to this number line is that if you are trying to put this in interval notation, you could see that we'd start at negative infinity and go up to negative 2. And we're going to exclude that negative 2 because this inequality wasn't an or equal to. So we go from negative infinity up to negative 2, or all the x's that are greater than 3 would start at 3 and go to infinity. So we have the final answer in interval notation is parenthesis negative infinity comma negative 2 union parenthesis 3 comma infinity parenthesis. So negative infinity to negative 2, or 3 to infinity. Let's look at one last example, less than example. So we have the absolute value of 2x minus 3 is less than 7. So what we're saying there is that this 2x minus 3 is sandwiched between 7 and negative 7. If you can picture it on a number line, the distance from 0 of 2x minus 3 is less than 7 units. So the 2x minus 3 is less than 7 units from 0. So that's going to sandwich it in between -7 and 7. I'm going to add 3 to the 2x minus 3 so I can get rid of that -3. -7 plus 3 is 4, less than 2x, less than 7 plus 3. And then divide both sides, or I'm sorry, all 3 pieces, not 2 sides. We've got 3 pieces. Divide all 3 pieces by 2 to further isolate that x. And we get that x is between 2 and 5. Putting that in interval notation, we'd have the interval that goes from 2 exclusive, so I'm using a parenthesis, not including the 2, up to 5, and that's our interval notation answer. I hope that these absolute value inequality examples have helped you. Couple things to look out for. One, watch out for anytime that we see a less than or equal to. In those cases, we're going to have brackets rather than parentheses. Same thing with greater than. But then if it's, I'm saying greater than or equal to. If it's just greater than or just less than with no or equal to, we've got the soft exclusive parentheses. The other thing I want to remind you of is that when we're working with inequality, and we have this case where we want to divide by -5 to isolate the x, what I have to do when I divide by a negative, like in this case, what I have to do is switch the direction of this less than. It becomes a greater than. So if in order to solve for x, you need to divide by a negative number, we've got to flip the less than to be greater than, or if it was greater than, we'd flip it to less than. But those are just a couple other things to look out for when you're working with absolute value inequalities.